Well, hello scrappers, chemistry enthusiasts, YouTubers of all sorts with a technological interest. Welcome back to my channel. Okay, it's been a long time coming, but today is the day. Today is the day I actually try and make some nitric acid using these waste mixed nitrate crystals I've been collecting from my own waste stream. Just to recap how I got these, I have a whole bunch of videos on how I extract gold and other precious metals from e-waste, particularly IC chips. And as a byproduct of that, I generate a lot of mixed nitrate waste. And over the past couple of months, I have been evaporating down a lot of that liquid waste and crystallizing out the mixed nitrates. It's mostly copper nitrate. But there's some other stuff in there. There's some probably nitrates of other metals in there as well. So it's a real witch's brew mixture of nitrates, and I have videos on getting these crystals. But today is the day I try and turn these crystals back into nitric acid, which is where they started. Because I have been buying a lot of expensive nitric acid to extract the gold and silver and other precious metals from e-waste. Well, that acid's really expensive, and I'd like to be able to recover some of my investment. So I'm going to try and turn this stuff back into acid. So, in the last video, I did a small-scale test to see if I could actually get nitric acid or nitric oxide out of these, because I could turn nitric oxide into nitric acid. So, and I was having some success. Now, before I set up my whole big distilling apparatus here and really go all in on this, I want to try another little test. Because in that last video, I put crystals in here and I put some sulfuric acid on them and then I heated it. And I got what looked like nitric acid boiling off. Okay, fine. I want to see if the sulfuric acid is even needed. I got a feeling if I just heat these crystals enough, as they are, they will dehydrate and start producing nitric acid, or at least nitric oxide, without the need for sulfuric acid. I could be wrong. It might not work. But I want to give it a test, just to see if the sulfuric acid is even needed or if it's a waste of money and chemicals. So we'll give that a try before I set up the big distillation apparatus. So after this test is over, one way or another, we're going to try and make nitric acid out of this stuff. Okay, let me get this in the fume hood and we'll get this test started. Alright, I've got these deep blue crystals in my smallest beaker, because I don't know what's going to happen here. This could be sort of a runaway decomposition. So I've got the smallest crystals, I've got these deep blue crystals in my smallest beaker. Got it up here on my brand new heat stir plate. I don't think we're going to need the stir function today, but we're going to need the heat function. So we'll get this lidded up, and we'll get it heating up, and we shall see what happens as this stuff warms up. I'm hoping to see the crystals will probably melt, form a liquid, because there's a lot of water hydration in them, and as they heat up, I'll bet those hydrated compounds will melt. So we'll wind up with a liquid, and the liquid will boil. There'll be a lot of steam coming off of it, but I'm hoping as these dehydrate and warm up that we're going to start getting some orange brown fumes coming off of them too. So we will see. So I'm just going to let that cook for a while and see what happens, and we'll be back. Okay, it's been a few minutes. Things are starting to warm up just as I expected. The crystals are starting to melt. About 113 C in there. So yeah, they're starting to melt. I'm starting to see some steam condense in the upper part of the beaker and on top of the watch, underneath the watch glass there. So yeah, things are starting to happen. I got the fume hood going just in case we start generating some fumes. So we'll let this continue to heat up and see what we get out of it, just as it is, without adding any acid. Now this is really starting to boil pretty hard in there. So far I see nothing but steam coming out, but I'm hoping to start seeing some orange fumes as it dehydrates and the salts start breaking down in the heat. We shall see if my theory is correct or not. Aha! We're starting to get orange fumes, and I have put no sulfuric acid in there. Okay. It just took a while. Probably took about 15-20 minutes to boil enough water off for the salts in there to start decomposing. Okay, so that's a beautiful thing. So yes, the first fraction I get over will definitely be mostly water. But then I'm going to start getting some nitric acid, or at least nitrogen dioxide gas, which are going to bubble through water and make nitric acid. And it looks like, yeah, the fumes are getting darker by the moment. That's pretty good. And I think what I will do is I will let this sit and cook until the fumes stop. And then I might try adding a little sulfuric acid to it to see if I can reinvigorate the process and get any more nitric acid out of it. Okay, so this is giving me a roadmap for how to set up my distillation apparatus. Oh yeah, now we're getting some serious orange fumes out of there. Wow. Okay, so I'm going to let this cook a little while. Wow, it is getting... I hope we don't have like a explosive runaway. Maybe I'll let the camera run for a while just in case we do, because look at the fumes coming out of there. My goodness. Glad I didn't put any more material in there than I did. Okay, so I'm starting to think that maybe the sulfuric acid I used on my first small scale test wasn't needed. Although I'm thinking I'm going to let this run until the fumes stop. And then I might put a little sulfuric acid in it just to see if it reinvigorates the reaction. Speaking of the reaction, I think I'm going to turn the heat down a little bit. Because this is getting kind of crazy. Yeah, wow. Okay, we're just going to let it run. That's a lot of fumes coming out of there from a small amount of crystals. Wow. Okay, we're just going to let this run and see how long it takes to stop. Well, it's been about 3 minutes and it shows no sign of slowing down. If anything, it's gotten worse. I mean, the fumes are so opaque inside the beaker, it's really dark in there, and look at the stuff just boiling out of the beaker. Wow. I mean, this is impressive. I couldn't have put more than a few grams of crystals in there. And look what's coming out. Amazing. Now, I think we've got the Energizer Bunny's cousin here. I mean, it's another 5 minutes and this is still going pretty strong. I think the amount of fumes coming out of the beaker has slowed down some, but it's still coming, and there's still a lot of fumes in the beaker. The material at the bottom of the beaker looks to have turned green. It was originally bright blue. So that's interesting. So I'm thinking once the fuming dies down a little more, I might try putting a little sulfuric acid in there just to see if that revives it any. We'll see. I gotta let it die down a little more. A few more minutes. Okay, it's been a little while longer. Things have calmed down a lot. Let's have a look inside here. Some dry green crystalline salt on the bottom of the beaker of some sort. Okay, so let me grab some sulfuric acid and we'll see what happens if I put a few drops of that in there. Okay, in the minute or so it took me to get the acid, the fumes have refilled the beaker a little bit. Let me see what happens. I'm getting a lot of white fumes. That might be just vaporized sulfuric acid. because that beaker is pretty darn hot. Well, now we're getting a lot more orange fumes again. Let me put some more acid in there. Oh yeah. Alright. So it looks like initially we're going to boil off a lot of water. So this is giving me a roadmap to how I'm going to do this with my big distillation apparatus. It looks like initially we're going to boil off a lot of water. Then we're going to start boiling off nitrogen dioxide and nitric acid. A lot of that. And then once that slows down or stops, it looks like I could put a little bit of sulfuric acid into the retort or the boiling flask and get more, at least nitrogen dioxide out. Once I wind up with those dry green crystals, it looks like the reaction can be revived with some sulfuric acid. Okay. So yeah, this test gives me a pretty good roadmap of what I need to do with my big distillation apparatus. So I guess it's time to start setting it up. Alright, I'm pretty well set up. This apparatus spans my whole bench and into the fume hood. I will give you a tour of what's going on here. So I've got my new hot plate stir plate, which I just released an unboxing video on, sitting over here. We're not going to use the stirring function today, just the heat function, because this thing gets really, really hot, and we're going to have to heat the heck out of the material in this boiling flask here to get the lovely nitrate fumes and nitric acid out of it. So this thing gets really hot, so we're going with it. Now, in one of my last nitric acid production videos, I haven't had this apparatus out in a while, because I used to make all my own nitric acid, but I started buying it when I needed it in larger quantities. So I haven't had this out in a while, but I was looking back at the comments on some of my older videos when I was making nitric acid, and somebody suggested I should use sand in here instead of oil. And we'll give it a try. I've got sand packed around the boiling flask here, and we'll see how that works. Certainly it'll be less messy than when it comes time to clean up than the oil was, I'm sure. I just hope I get good heat transfer into the flask. And of course, the sand's going to be able to handle much more heat than the oil could. The oil would get smoky, and I'm planning on heating this up even hotter than I was getting with the oil. So, okay. So we got the hot plate, the boiling flask, 2-neck boiling flask. Got thermometer adapter up here, so I could monitor the temperature. We've got a condenser here, which I'm going to pump ice water through. I've got a cooler down here, which I will fill with ice and water, and it's got a little 12-volt pump in it that will pump the liquid up through the condenser, so that we can condense all of the nitric acid goodness there. I'm going to come over here to a receiver flask, which I'm pretty sure in the beginning we're just going to get mostly water over here into the receiver flask. So I'm going to wait until we get the water out of it, until it looks like we're starting to get nitric acid over, and then I will swap out for this nitric acid storage container, and we'll start collecting it. And I'll probably take the liquid that we get here, and I'll probably dump it into this thing down here. Now there's probably a highly technical name for this in chemistry laboratories, but I am calling it a suckback preventer. That's my name for it. Because the next stage, I'll show you the next stage over here, but if there were to be a vacuum formed in all of this equipment over here, because I like turn the heat down or something, decide it's running too hot, turn the heat down, it cools down, pressure might fall below atmospheric. I don't want to suck water from the next stage back into here. So we've got the suckback preventer, and it's basically just a mason jar with a couple of glass tubes going into it. And you know, I'll put a little water in this later. Probably the first water I get in the receiving flask, and as the nitrogen dioxide gas passes through here to the next stage, some of it will dissolve in the water and we'll get a weak nitric acid from it. Okay? And then the last stage in the process is inside the fume hood, because this is where all the fumes are going to be coming out ultimately. And what I've got here is a 2-liter beaker with a graduated cylinder inside it, and the hose from the suckback preventer is going to go down to the bottom of the graduated cylinder, and I'm going to fill that with distilled water, and I will pack ice and water around the graduated cylinder, so this will be nice and cold, and any nitrogen dioxide fumes that are coming bubbling out here hopefully will dissolve in the water inside this graduated cylinder and make some more nitric acid. So hopefully what we'll get here is a dilute nitric acid. What we'll get here is a weak nitric acid, and what we'll get here, once I switch over to this bottle, will be a fairly concentrated nitric acid. That's what I am hoping. We will see. So I've got some more setup to do. I've got to get everything iced down. I've got to get things filled up with water. I've got to get the crystals in the boiling flask. And yeah. Ooh, and it's already starting to get hot. It's only a little afternoon. It took me a while to set all this up. It's going to be a hot afternoon, so I'll be sweating while I'm doing this. You can watch me sweat in air-conditioned comfort of your own homes while I make some nitric acid, or at least attempt to. Okay, let me get back to work. I'll be back when we're ready to fire this thing up. Okay, I think everything is ready to go except for getting the crystals into the boiling flask. So that's my next job. They're probably not going to want to go because they're damp. Yeah. Think about how much to put in here too. The reaction with my small test was pretty darn vigorous, so I don't want to have any kind of like runaway reaction here. But I want to have enough in there to make, you know, a reasonable amount of nitric acid too. Oh, these crystals have all decided to consolidate since I put them in this jar only a few days ago. Great. Had a heck of a time of breaking them up and getting them out of the beaker originally. Now I'm going to break them up and get it out of this jar. Alright, while I'm doing this, I think I'm going to turn the heat on because it's going to take a while to get this thing up to temperature. And it might help if I plug the thing in, huh? That might help. There we go. Plugged in. On. Yeah, because it's going to take it a little while to get up to temperature, so, okay. Oh man, these things are just consolidated into one solid mass. That stinks. Only the ones on top were kind of loose. Everything else is... yeah. Well, I'll have enough for a decent test. Anyway, see if I get any nitric acid out of this stuff. Any real nitric acid, you know? Alright. Let me see if I can break a few more loose and get them in there before this thing starts heating up and the reaction starts. Okay, problem solved for the moment. I just went and got the other jar. The crystals in it aren't quite so consolidated, so I can get some more material in. Okay. That's starting to look like a fair amount of material in there for a test. I can always add more later if this looks like it's working. Of course, then I'll just... maybe I don't want to do that because I'll be wound up putting... if I put fresh crystals in there, I'll start boiling water off again. And I don't want to have to go through that twice. So let me put a little bit more in. Alright. I think if I decide to do this, if I decide to do more, I'm going to have to start over from the beginning, I think. Otherwise, I'm going to contaminate everything with water. Okay, from these wet crystals. Yeah. Does that look like enough? Well, it's a lot more than in my small scale test, so we will go with that. See how it does. Okay. So this is starting to... oh yeah, starting to heat up. So I will wait until I start seeing something happening before I turn on the water flow in the condenser. I don't want to waste my ice water down there because it's getting to be a warm day, and why waste it if I'm not condensing anything? Okay, be back when something starts happening. Okay, things are starting to warm up, but it's going to take a while, I'm sure, because there's a lot of sand here that needs to be warmed up. So what I'm going to do is I'm going to build an aluminum foil tent around this just to keep the heat in. So the breeze out here doesn't tend to cool it off too much. This really helps when I'm doing my nitric acid distillations. Yeah, that's going to take the heat from the plate down there right up past everything. Okay, keep it in there. So, all right, now it's just a waiting game. Got to get it to warm up. Gonna take a bit. Well, while we're waiting for it to get hot and something to happen, I'll give you another look at the apparatus. You know, the boiling flask is in the pot, basically, with the sand on top of the hot plate under the aluminum foil. Got the condenser. Got a tub full of ice water down here with a 12-volt pump in it that will pump liquid through the condenser. Already got the condenser primed. We got the receiving flask down here. It's going to take the first liquid to come off, which is going to be mostly water, I'm sure. And then once we're getting some nitric acid, I will switch over to this bottle over here to collect it. I will probably dump the liquid from that receiving flask, the first water, into my suckback preventer, just so it can get enriched as the nitrogen dioxide fumes pass over it in there. And then over here in the fume hood, we've got the hose going in there and a glass tube going to the bottom of that graduated cylinder, which is full of distilled water. And it is in a 2-liter beaker packed with ice and water to keep it cool, so that nitrogen dioxide coming through there and bubbling up through the graduated cylinder will hopefully dissolve in the water and turn into nitric acid too. So we should get nitric acid 3 different ways, 3 different strengths. And fume hood's not running right now because we're not producing any fumes. I will turn it on once we start getting fumes through and exhaust them far, far away from me. All right. Now we just gotta wait for something to happen. Alright, it's been a few minutes. Let's peek up under the skirt, so to speak, and see what's going on in there. I don't know how well that's showing up, but yeah, those blue crystals have melted into a puddle in there. And I'm starting to see a little bit of bubbling. Good. Excellent. Alright. Yeah, and I see steam condensing up here. The temperature's almost up to 100 F up here. I see steam condensing over here, so let me get the condenser circulation going. There we go. And we can condense that steam as it comes out and collect the water down here in the collection flask. All right. So things are starting to happen. Good. Excellent. So I imagine we're going to be getting water over for quite a while before we start seeing significant amounts of orange fumes. That's what happened with my small-scale test. So we'll just let this run and see what happens. Starting to get some water dripping into the receiving flask over here. So the steam is coming over and condensing. Okay. So that's good. When those crystals dry out a little bit in there, then we'll start getting the good stuff. Right now we're just getting the water. Okay, I just peeked under the aluminum skirt again. Got some vigorous boiling going on in that puddle of blue liquid in there. The water's coming over pretty quickly. So yeah, exactly what I expected to happen. The temperature on the thermometer up here is just shy of 120 C. So yeah, and I can see here in the end of the condenser we got a lot of vapor condensing out on there. So yeah, I got some vapor condensing out on the outside of the condenser too because I'm pumping ice water through it. Okay, things are moving so far just the way I expected. We'll see if it keeps going the right way here. Oh, we're starting to get a lot of water in the collection flask down there. Let me have a peek inside the foil. The temperature is up to about 130 C on the thermometer. Let me have a peek inside the foil and see if we're getting any orange fumes yet. I would say no, not yet. So it's got to cook a while longer. Let me get this back on here quick before the heat gets out. And let it keep cooking and keep dehydrating. Well, it's just a couple minutes after that last segment, and we're getting a tinge of orange in the receiver arm over here. I'm sure this is still mostly water coming through, but hey, this is a good sign. Let's see what's going on in here. I don't see any bubbles coming up yet. So I guess we're not really evolving that much gas yet. Or it's dissolving in the liquid in the receiving flask. I don't know. Okay, so this is telling me it's probably getting close to time to change out the jars, but not just yet. Not just yet. Okay, I think I'm about ready to change out the receivers here. Get this jar ready. It needs an adapter. Okay. Let's see if I can do this between drips. Probably unlikely. Well, maybe. There we go. Okay. That's starting to look like we got some nitric acid in there. It's going to be weak, I'm sure. Mostly water. I'm going to dump it in the suckback preventer here. Orange fumes in the bottle. And we're just going to let this go. Okay. Unfortunately, with this opaque bottle over here, we're not going to be able to see the drops going into it easily. I can if I get down here and stick my head down there. They're coming over pretty darn frequently. Probably a little more than one a second. And there's probably starting to be a fair amount of nitric acid there. I'm sure it's not full strength, but even dilute nitric acid will come in handy. Okay, so we will just let this continue to cook. Oh wow, the temperature, that's probably not going to show up. The temperature of the thermometer up there, it is up to, it's above 140, about 142 or so. So I would say we've probably cooked off the bulk of the water in there, and what's coming over now is probably nitric acid. Probably still not full strength, but probably nitric acid. We're getting some. Okay. Gotta let it cook. As I recall with the, if you recall with the small scale test, it produced fumes for a long time. So, we'll let it go. Okay, the drips are coming over into the collecting bottle quite a bit faster than they were. So that's good. Starting to get some serious liquid accumulating in there. Fair amount of orange fumes over here. I'm still not seeing any bubbling over here. I can see where the meniscus is on the liquid. It's, I don't know, a centimeter and a half below the top of the water. So I guess we just don't have enough pressure to blow a lot of nitrogen dioxide over here, or I have a leak in the system, which is possible. But because I'm using the wrong kind of hose, and actually I'm using the wrong kind of everything, but I've kind of cobbled it all together, fabric cobbled it. So there is a little bit of pressure from where the meniscus is. I'm thinking what's maybe happening is we are just producing nitric acid at the moment, and it is mostly condensing in the condenser and dripping into the jar. And we're not producing a lot of nitrogen dioxide, which doesn't condense. At least not yet. Maybe given time, we will. I think that meniscus is a little lower. We'll see. Okay, yes, I found a leak. There were orange fumes coming out here. This wasn't seated properly in the adapter. Okay. So that explains a lot. And yeah, I don't see the meniscus anymore. We may actually start getting some bubbling now. It looks like the meniscus has gone down below where I can see it into the water ice. So, okay. Yeah, the system was leaking. So, I got a whiff of it, and then I followed my nose to see the little orange fumes leaking out here. So, okay. Oh, look at the nitric acid condensing and running down there. Wow. That's nice. This is a waste product. I'm making a valuable reagent from a waste product. I'm loving this. Okay, yeah. Now we're getting a lot more fumes in here. Now we've got another leak here. Okay. Yeah, this system's not sealed all that well. to see if I can seal it up a little better. Alright, it looks like I just can't seal the system up enough to get any bubbling going on over here. Any back pressure at all, and the gas starts leaking out around that joint over there, unfortunately. Now, these adapters don't really fit together all that well. I don't have Keck clips that'll go on them. So what I've got is I've got a fan at my back blowing air that away, so I don't have to breathe that gas coming off. So unfortunately, that's a bit of a problem. Okay. So in the future, what I will likely do is maybe get another receiving flask like this one, where the joints are going to fit together much tighter, and I can put Keck clips on them. And maybe I'll use that to catch the early water, and this to catch the nitric acid later. Yeah, that might be a good idea. In fact, if it weren't fuming so bad, I'd switch them back around. Now that I've dumped the water out of this one, I'd switch them back around, but I'm afraid I'll get a face full of fumes if I try that right now. Okay, I've got a fan blowing at my back. The fumes are going that way. I'm going to be careful and quick and see if I can swap these out. Uh-oh. There it goes. Lap jack back up. This reconnected. Okay. Get this. Alright. Alright. That's a little better. It's not leaking. Let me find a Keck clip and put it on there, and we should have an even better seal. Oh yes! Holy cow, look at this. Yeah, we've got a better seal. Thank you! So yeah, we've got a better seal. So what I think I will do maybe is put the glass tube back on that. So hopefully it'll bubble in at the bottom, and as the bubbles rise up through the liquid, they'll have a chance to dissolve in that cold water. Okay. Alright. That's better. Okay, all is not well. We've kind of reached the end game here. We're not getting near as much nitric acid coming over as we were earlier, but boy are we producing the nitrogen dioxide gas. Now I wanted to capture that gas. You could see how dark that clear glass flask is there, and the receiver arm up there in the of the condenser. Yeah, and look what's going on down here in the suckback preventer. But my problem is I just can't seal the system up enough. My main problem is the suckback preventer. I don't know if you can see little streamers of gas coming off. Yeah, it's coming off pretty bad. I've tried to seal it up really good. I got the hot melt glue gun out and just slathered it all over it, but it's still leaking like a sieve. So since that's leaking, I've got no pressure in the system over here to make bubbles. I mean, the least little bit of back pressure, and there's no bubbles. So yeah, so we're not capturing that nitrogen dioxide gas. It's just escaping at this suckback preventer. So it's all going to waste. All this lovely nitrogen dioxide gas that we're producing by the cubic foot here is just going to waste, unfortunately. So I will need to fix that before my next run. Do something a little better with the suckback preventer, and probably get a little more scientific about this. This was a good test. I made some acid. There's some acid collected in that flask there. There's some acid collected in the brown bottle there. I'll probably combine them. I'm sure they're both pretty potent. Got some acid in the suckback preventer. It's gonna be a lot weaker, I'm sure, but you know, with all that nitrogen dioxide in there, dissolving in the water in the bottom, it's turned yellow. I'm sure that that is, you know, going to be some fairly potent dilute nitric acid. So that'll come in handy too. Even dilute nitric acid will come in handy. But yeah, there's some room for improvement here for sure. I'm just not capturing the nitrogen dioxide, which I could convert into a lot more nitric acid if I could capture it. So that's where I need to improve things. Okay, I think we're winding down here. My small scale test produced brown fumes for a long time, but since I'm not capturing them, I don't know if I want to bother continuing with this. I may turn the heat off and let things cool down. Let's get a look under the aluminum foil and see what's going on. Okay, let's see what's happening in here. Oh my. Well, there is so much nitrogen dioxide in there that the flask has gone opaque. Uh-oh, melting a Keck clip. It got hot in there. Somewhere I have some stainless steel Keck clips. I'll have to... Note to self, next time use stainless steel Keck clip at that connection. Okay, maybe at this one too. Yeah, I got pretty darn hot. Okay. Let's see, and it looks like we've had a lot of splashing as the boiling has happened. I can't really see what's going on in the flask, but let me turn the heat off. I think we're done here for today. And I'll just let this cool down on its own, leave the circulating water going, and we'll see how much acid we collected after everything cools down and the fumes dissipate. In fact, what I think I will do is I will disconnect. Yeah, speaking of dissipating the fumes, sorry, don't want to give you vertigo. I think I will just pull this hose out of there, okay, and just let the fumes go into the fume hood, and I'll turn the fume hood on and dissipate them that way so I don't have to worry about possibly getting downwind from the suckback preventer. Okay. Alrighty. So we'll let this mess cool down and we'll see what we got. Well, it's been about 20 minutes. The temperature on the thermometer has fallen below 40 C. There's still too much nitrogen dioxide gas in this flask to see what is left in the bottom of it. And boy, this thing is still hot too. It's going to take a while to cool off. I have changed from nitrile to latex gloves because there is a little puddle of what is probably very concentrated nitric acid right there. And I'm going to try and get that to come down into the receiving flask over here. And you know, if you've seen my other videos on making nitric acid, if you've got really concentrated nitric acid and you get it on your nitrile gloves, they're apt to just burst into flames. So, yeah, so we don't want that to happen. There's actually some here too. Let me get this half melted Keck clip off. See if I can break the joint here without breaking any glass. Oh, it doesn't want to come apart. Huh. Get this Keck clip off. Oh, they want to be... they're all seized up. What am I going to do here? How hot is that? There, I'm getting it to run down for the most part. Uh-oh. Don't fall off. Okay, there we go. Alright. I think I will just continue to let it sit and cool before I do something stupid here and break some glass or something. And then I'll do as I usually do. I'll get a tub of water, put some baking soda in it, take the glassware apart piece by piece and dump it all in the tub of water with the baking soda to neutralize the acid on it. Okay. So I guess I'll just let it sit. Okay, I got a bucket of water down here. I've put a lot of baking soda in it. I'm going to start carefully, slowly and carefully disassembling the glassware and dumping it piece by piece, well, placing it piece by piece in there to neutralize the acid on it. I'm going to dump it in. I'll break something. Alright, so let's get started. It's going to take a while for all this to dissipate. Let me turn the pump off first. Stop the water flow. Okay. Uh-oh. Suckback preventer wants to fall over. And this wants to fall over. This is the part I hate. Sometimes you need 3 arms. Okay. Get the clip off. See, now this arm has acid in it. Oh yeah, fizzing. Lots of fizzing. Okay, get this hose off. Get this hose off. That's just water draining out of the condenser there. Ah, there we go. Okay. That's got acid in it. Yeah, lots more fizzing. Ah, there we go. Oh yeah. Thermometer out of there. Okay. Pull that out. Put that in. Where's my other stopper? Stopper this up. Not very much. Not very much. There's a lot more in here. Altogether, though, I'd say probably only about 100 milliliters worth. I'll have to combine them and measure them. Do that later. Okay. So hopefully, you can see there's a pretty good demonstration that nitrogen dioxide is heavier than air because it is not coming out of that. It's just staying there. So we'll just let it slowly dissipate as the breeze blows across it. I may move the fan closer so that as the wind blows across it, it'll cause it to dissipate. In fact, when I do that, it's dissipating some. And we'll get a look at what's in the bottom of the boiling flask. Okay, the fumes have dissipated. It's a while later. Got some very green sludge in the bottom of that. Not sure what we've created in there. Not sure how to get it out either. Now, the stuff in my small scale test wanted to stick in the bottom of the beaker, but I added sulfuric acid to it. I haven't added sulfuric acid to this. So I'm hoping that will come out fairly easy, although I'm thinking, which is always dangerous, but I'm thinking maybe I'll just leave it in there and put more crystals on top of it for the next test, because I aborted this early. I think I can cook more nitrogen dioxide out of that. I don't think it's done. So I may leave that in there, and the next time I do this test, I'll just put more crystals on top of it. Of course, that's going to throw my yield calculations off a bit. I don't know. Anyway, this is too hot to do anything with still, so I can't like put water in there yet and try to dissolve it. What I'll probably do is put some of the water from my bucket with the baking soda in there, and hopefully that will dissolve whatever that green stuff is in there and get it to come out. It works when I'm making nitric acid with sulfuric acid and sodium nitrate. It dissolves the sodium sulfate and bisulfate that's in the beaker pretty well. Okay, and only destroyed 1 Keck clip this time. I'm usually destroy 2 or 3 when I make nitric acid, so hey, only 1 Keck clip down, but I didn't make very much acid. I'll show you that next. Okay, like I said, I didn't make very much acid. Now this is the acid from the bottom of the suckback preventer. As you can see from the color, it's got a significant amount of nitrogen dioxide dissolved in it. So I got about 33 milliliters of it here. I got a piece of seashell here, which is basically calcium carbonate. Let me get a little bit of this stuff. Oh yeah, I don't know if that reaction's showing up. So we got some just dilute nitric acid here in this graduated cylinder. So what I'm going to do is I'm going to combine the liquid in these two containers here, because this is my stronger nitric acid, and I'm going to put the stuff in the cylinder here into this container. Then we'll measure how much of the strong acid we got. Okay, I've poured my weak acid into this container here, and it can just soak up the rest of the nitrogen dioxide in there and become a little stronger. This is the strong acid, so altogether we only made about 26 milliliters of it, but that's going to be some really concentrated acid. So, didn't make a lot of acid on this, didn't make a whole lot of acid this time, but there's definitely potential here. I mean, I didn't use very much of my starting material. I still have an awful lot of those pretty blue crystals and green crystals left. I can do this all again several times and be a little more scientific about it. I need to work on my suckback preventer. This thing turned out to be a disaster. I mean, it worked for making the weaker nitric acid in it, but it didn't seal, so it didn't pass the fumes on to the next stage. So I didn't get anything in my graduated cylinder in the fume hood. Nothing. So yeah, let me get this stuff bottled up, and look how it fumes when I pour it. Yeah, that's some strong acid. I don't think it's strong enough to set gloves on fire, but that's some pretty strong acid. I'm thinking that next time we do this, we'll be a little more scientific about it. First off, we'll improve the equipment some so that it works a little better, and then we'll measure out our starting materials, and we'll measure our yield by measuring how much acid we get. We may even be able to determine the actual strength of the acid by measuring its density, because there's tables online of nitric acid density versus strength. So yeah, we can probably do that. I don't think there's enough here for me to bother with, but with doing that. But in the future, yeah, we could do that. I'll get my system set up a little better, and we'll do that. I think I could start with a larger amount in here too, and if everything is sealed up good, we should be able to turn some of that nitrogen dioxide that was boiling off just to beat the band at the end into nitric acid too. And I'll tell you what, wasps love the smell of nitrogen dioxide. I don't know why, but they are swarming around that graduated cylinder. So okay, it's still pretty hot, but I got to start cleaning some glassware and drying it and hanging it up, and I got to see if I can clean this out, and we'll do this again real soon and see if we get any better results. So I'll see you in that next video. Thanks for watching. If you found this video at all interesting, give it a thumbs up. Give it a like if you found it at all interesting, educational, inspirational, whatever. Give it a thumbs up and a like. Subscribe to see my future videos, because they are coming out. I've got a couple more in the can already, and then I'm going to make another one, hopefully with better results than this. Although this is not bad for a first try. And so yeah, more videos in the future. Subscribe to see those. Press the little bell icon YouTube makes you press to be notified when new videos come out. Check out my second channel. Got new content going on in there too. Subscribe there. Press the bell icon there too. And we'll see you in the next video. Thanks for watching. Bye. Okay, I figured out how to clean this stuff out. I put some of the water that has baking soda in there. There was some fizzing and some whatnot, but there was a great big puck of green stuff in there. I had to break it up with my long screwdriver carefully so I didn't punch a hole in the bottom of the flask, but still the pieces were too big to come out through the necks. So I've got this on the heat right now. I've got a stir bar in there, and it looks like all those pieces are breaking up into a powder. So I should be able to pour everything out of the flask and get it good and clean for the next run. So I think I lucked out there. I'm able to get that puck of crap out of there and wind up with a nice, clean, boiling flask for the next run. Alright, after doing a little quick research online, I figured out that that puck of green, and there was black stuff in there too, is copper oxide. Okay? I was having trouble even with the stir bar breaking the pieces up small enough to come out the neck, so I did a little research. And, well, a little bit of sulfuric acid has turned it into copper sulfate. And it's almost all dissolved. There's no more pieces in there. I can just pour this stuff out. I'll pour it into my waste bucket and I'll cement out the copper. And yeah, so that was easy. Okay, problem solved. My boiling flask is going to be good and clean for the next time, and I know how to clean it out next time. Okay, there's your bonus material. I'll see you in the next video. Bye.